Yes, welcome back to Phone Lookout. So today we are going to look at the earphone pin or headset pins or headphone pins. So basically we are going to look at the earphone slash headset slash headphone pin. Now I know most of you may not be able to tell the difference between an earphone and a headset pin, but then we are going to also cover that in our video today. Now if you're new to the channel, please do subscribe, and if you have already subscribed, please do click on the like button if you love our videos, and if you have any queries, please do comment and do watch our other videos. Now, so today's video is about the earphone pin, the headset pin, or the headphone pin. Let's go right in and get the headset and earphone out of view. So this is the subject of today's video. These two guys, I bet none of you can spot the differences between these two, but one of them is for the earphone, the other is for the headset. So basically, to understand the earphone or slash headset pin, one has to know basically two things, that is conduction and insulation. If you haven't watched the video where I talk about the earphone wire, conduction, shorting, and insulation, this is the time to go right there and click at it. I'll leave it there at the top right corner, right there at the top right corner. I don't know whether you see it right there. That's where I'm going to leave the video about conduction, shorting, and insulation. Okay, just as we said earlier on, to understand the earphone pin, you simply have to understand two things, and therefore three things. That is the subject of conduction and the subject of insulation to prevent shorting. Yes, please do watch that video on the earphone wire that covers conduction, shorting, and insulation. Please do watch. So basically, this is what the earphone or slash headset pins look like. Now if you notice, these two a bit different if you look carefully, and please do not tell me they look different because they are of different colors. That does not count. Anyway, when you look at these two carefully, look at that. This node is identical to that one, and when you look at these two, that's actually metal. This node is actually the same size as this one, and then when you look at this one on this has been divided into 1 and 2. Basically the overall length from that point to that point is the same as the length from that point to that point. So that's some bit of the similarities in here, and basically one of them is the earphone pin and that is the headset pin, but both could work as headphone pins. Now I bet you're asking me what's the difference between the earphone and headset. Basically the earphone simply is used to listen to music and nothing more, whereas the headset is both used to listen to music and also receive calls, meaning that an extra component is added on top of the two speakers for hearing music, and that component is the microphone. Of course, some headsets go ahead to incorporate the receive button, and that also has to be factored for, and that's why you will see that this pin for the headset has 1, 2, 3, 4 nodes. I'm calling them nodes, and then the white part, that's the internode. So basically, as we had said earlier on, that to understand the earphone slash headset slash headphone pin, you have to understand the concept of conduction, shorting, and insulation. Now we know all that metals are conductors, and insulators tend to include plastic, wood, paper, and so on and so forth. Conductor is just like we said earlier on in the previous video, any material or object that actually allows the free flow of electrons, whereas an insulator does not allow free flow of electrons. So we tend to use non-conductors. In other words, we tend to use insulators to prevent shorting or for insulation, and conductors to transmit power or current. Now we also mentioned that all metals are actually conductors, so keep that in mind. and all metals when polished actually are shiny. So when you look at that shiny part, that's actually metallic parts. Now, so when you look at this pin, let's begin with the earphone pin. When you look at this pin, this piece of metal, if you look at it carefully, has been made into some sort of L shape. We will just cover why that is so in a bit, but for now let us cover the concept of conduction in the earphone pin. So this pin is basically a metal that's to conduct power from the phone or device that is producing music into the wires and further into the earphone speakers. Now, if you look at this outer metal thing, this is actually tubular, and being tubular, inside it is inserted a plastic tubular material to also help with insulation. Now, having inserted the plastic insulation, there is other piece of metal. Now this metal is also tubular, but a much smaller tube, and passes through the center of this insulating plastic, which is in the center of this piece of conducting metal, and comes up to this point. So you can see this plastic is passing through the center of this tube and appearing on this side. It comes from this side under the tube to that point, and then that piece of metal passes under that black plastic down up to here. Now this other last one also passes in the middle of that insulating plastic, which insulating plastic passes in the middle of this piece of conducting node, and that node passes in the middle of that insulating plastic that passes inside the middle of this other conducting tube. Now that then comes up to this end. So when you look at this 1, 2, 3 metal pieces, actually none of them is joined to the other. This does not make contact to that. By contact I mean electrical contact, and this does not make contact to that due to that insulating layer of plastic. So basically what we have to do, let me now just bring my multimeter and just prove to you that those two are not touching each other and therefore do not short to each other. So now I brought my multimeter, and my multimeter allows measure resistance. Basically resistance is the opposition to flow of electricity. Therefore we tend to know that something is a conductor by reading its resistance. This resistance will be very low. It has very low ability to oppose the flow of electricity, so it will read a low resistance value. For instance, now when I touch this piece of metal to that metal, you will notice that my multimeter will beep and will read for me 2 ohms. So now that is for a conductor. For instance, if you were to put this right here on that, and right there, it's conducting. So this is one piece. Now insulators on the other side, for instance plastic, if I were to put these 2 probes across it, it would actually not conduct electricity, and therefore I wouldn't get any reading there. Now one other thing that I need to say is when 2 metals are far apart, like this is far from this one, in the middle there is sort of like insulation, nothing is happening, no power is flowing. So for instance, if I put this in between these 2, nothing will get there. Let me just now test for you as to whether this metal part and the next one, I don't know whether you're able to see. Okay, let me place it there on the ground where it seems a bit in frame. So now remember when I touch this and there's conduction, I get that low resistance and a beep. Now when I put this to that, I don't get anything. That means these 2 are not touching each other. This part of the metal, just a moment, sorry, it's running. That metal is not making any electrical contact with that metal. That's why I don't see any resistance. Even here I don't see no beep, no nothing on the multimeter. So that proves to you that this and that are not connected in any way, and this and that are not connecting in any way. However, that point and that are connected because that's one tubular piece of metal. Now let me again zoom in a bit and draw it somewhere there. Now when you look at this one, when I tap there, just a moment, let me focus. When I tap there and the corresponding end, you see it makes noise, so that is passing in the middle of this other one to that point. When I tap from this one to the extreme end, I also get a beep. So this piece of metal goes in the center, that plastic to that end. This one also goes to the center of that to there, and that is one piece. Now it goes without saying that that is also the case with this other one. It's using the same principle, except that this one has more tubes. Now just to give you a bit of a demonstration of what's really happening, let me try to see if I can actually pull out the individual conducting tubes and their corresponding insulations. Let me first trim off that point, that solder. Let me see if I can pull this out from the center. Feel it rotate. Not much is happening. Let me again trim it some more. Okay, so I think you can see what I was talking about. I think that thing is actually tubular and hollow. Do you see right there? So the outer thing is tubular and hollow, and then there's a piece of plastic around the next tubular thing that enters right there. Now, having removed that out right there, the next thing, let's try to see if we can also get the other one out for the sake of demonstration. A lot of white around, so it might be a bit hard to focus, but let me see if I am in position to pick out the other inner one. Okay, yeah, so now this is what we have. That's how this would look like when we break it down. That, like that, like that. Yeah, so basically that's how your earphone pin looks like. This other one would also look like this if we plucked it out. Okay, when you look at that piece of metal right there, if you look at it, this piece of metal has that piece of plastic that is an insulator to insulate it, and then after that it enters in the center of this one right there, so it ends up not touching that piece of metal, just passes through its center. Yes, it just passes through its center like that. Okay, you get the idea. So that piece of metal is insulated by that piece of plastic and then passes through the center of this piece of metal and comes out on that side. Then this actually enters into that. So that's how this pin is designed. In other words, this is insulated from that by that black thing you're seeing right there, and this is insulated from that by that dark thing you see right there. And let me just pull them out and you have a look of what's happening right there. So that's what I mean by that. So that's basically how the earphone pin looks like. So never be a bit confused as to why this and that have that black separating ring. That's actually to insulate them from each other as they form that, because we have to give power here, we have to give power there, and this has to go to some point. So you do not want these three pieces of metal touching each other and shorting themselves out. Now that's the beauty of the earphone pin. Now for just, let me just put it alongside the headset pin. Basically that's what we have. I don't know, let me just looked cool when I had separated it like that. and this like that. So this is what we have ourselves here. Ain't that beautiful? So just for comparison, for this case they used a white piece of insulator or plastic to separate that piece of metal electronic. I separate it from this other one, and also we separate that from that one, and also separate that from that one. White, this white separates that from that, this white separates that from white, from this white separates that from that, and that's what you have there. So you might be asking me, what else? Now, let me just bring back my headphones a bit. Now, if you look at, okay, let me begin with the earphone. So let me bring back my earphone. Now, if you look at this, when you look at the length of that pin and that pin, clearly it goes without saying that it's only from this point up to that point that remain exposed. This other one behind these ends actually just provide for soldering points, for points for attachment of the wire. So ideally, why this has to pass through the center of this to come to this side, and this through the center of that to come to that side, is because at this side we want to connect our wires so that power passes through them to the earphone speakers. Now, also with the headset, let me bring headset. This was for the earphone. Okay, that was for the earphone. Now for the headsets, if you notice, it's something similar going on. So when you look at for the headsets, what's happening is that you have this length up to that point equaling to that length up to that point. So when you look at this other, from this point to this point, that is actually to provide for points where wires should be connected. And you can see some signs of solder. This was solder, wire had been soldered there, and then another wire was soldered right there, and the other one soldered right here, and then to the last. So when you look at this one has actually 1, 2, 3, 4 nodes separated by 1, 2, 3 insulating internodes, and therefore we have to have 4 corresponding solder points: 1, 2, 3, 4. So you might be asking me what's happening here. So this soldering point corresponds to that point. This other second soldering point corresponds to that node. Then this other soldering point corresponds to that other node, and then finally this last one corresponds to that last node. So about this point they are mirrored. So if you want to get the farthest connection, it's on the farthest end, this ends of a connecting point. The next farthest is followed by the next farthest on this end, and this to that, and that to that. So that's how the pin looks like, and that's how the pin is, so that you do not get confused when you reach on the earphone / headset pins. So these guys should never confuse you a bit at all. I bet you might also be asking me, even this one has 3 points of this one actually has 3 points of connections, because there are only 1, 2, 3 nodes. So the first point of connection is here. Let me zoom in right there. So our first point of connection is that one right there, and then the next would be on this other cylinder, and then the other would be on this last one. So that's how the pin actually looks like. Okay, it just keeps feeling cool when I pull this out like that. You see, that's your earphone pin. I love the ingenuity that was done right here. Yeah, right there. It is very ingenious. So basically, that's what we are having. Okay. So right now, do watch Phone Lookout, do subscribe, share, and like. Just to recap, I told you that to understand the earphone or headset pin, one has to understand the concept of conduction, shorting, and therefore insulation. We have a conductor there and an insulator, a conductor there and an insulator, a conductor there. So this conductor is insulated by this insulator from that conductor, because this has to go through the center of that. Now this conductor itself is insulated by that black thing from this conductor, because that has to go through the center of this, and that's how the earphone or headphone or headset pin is designed. And this right here with four nodes is the headset pin, because it has to accommodate another component, which is the microphone, and also occasionally a button to receive the call. After having known that, then you need to know that the connections of these pins are mirrored to that side, in that the connection from that point to that, the connection to that point is this extreme one, extreme node, extreme connection point, soldering point of the wire. Next extreme node, next extreme soldering point for the wire. The middle, that node, its soldering point is right there, and that node, of course, right there. So for it, it's just a tube, a continuous tube, the way you see this. So on this end, they provide the point to solder it. Now, there's one last thing that I was going to miss out, is why that part is made triangular, the tip of the pin, why it is made triangular. That's to provide resistance when the headset is plugged in, so it does not plug out. So when you plug this into the earphone jack, there is a terminal that comes and locks into place, in that for this to slide out, you need more force for it to slide out, because that area is much that cross section is much wider than this other one. So it's like a spring mechanism to help keep your earphone from slipping out easily. What else might I have to answer? What else? I don't think there's anything more, but that's the mechanism by which these earphone pins or headset pins or headphone pins remain in their audio jack, is because the triangular nature makes it lock into place with its terminal of contact. So do share our videos, and please come back in the next video, because in the next video we are going to cover how the pin, the wire, and the speaker are connected in an earphone. Yes, you made me asking me why, because we have already covered the science and basic principle of the earphone speakers. We have covered the wire, and then now we have covered the pin. So the next thing is to show you basically at the very basic level how the speakers are connected by the wires to the pin, to the earphone pin. So thank you for watching. Come back next time.